Hello friends, welcome back to the class of thermodynamics. In today's session we will see what is the second law of thermodynamics. Till now we have seen about zeroth law of thermodynamics and first law of thermodynamics and some limitations of first law of thermodynamics because of which second law of thermodynamics came into existence. What were the limitations? First law doesn't tell about feasibility or possibility of process. Second thing, it doesn't tell us about the flow of energy, means flow of heat transfer. Correct? Now, there is one more limitations. What is that limitation? Write in the comment box. Because of these limitations only, the second law of thermodynamics comes into existence. Okay? Now, we will see what is the second law of thermodynamics. So, in second law of thermodynamics, there are two statements. Kelvin Planck statement and one more statement is there, Clausius statement. Now, what are these statements? I will tell you. See this figure carefully. There is hot reservoir source. Here there is working substance, means engine or some system. Then this blue color is cold reservoir or sink. Now, second law of thermodynamics is a fundamental law of nature, which explains that heat can only flow from hot body to cold body by itself. Second law is nothing but it is law of nature. In nature, what is happening? The energy flow from high temperature to low temperature by itself. You know this thing. But what about reverse? When the energy can the energy transfer from cold temperature or low temperature to high temperature by itself? No. See, this is not only second law of thermodynamics. It tells about the direction of the flow of energy. Okay. Now, second law of thermodynamics is fundamental law of nature. Note down this important thing. Second thing, it explains that it can transfer from hot body to cold body by itself. In the reverse direction means for heat transfer from cold body to hot body, it requires some external work or something. Okay, it is impossible by itself. It requires some external agent. How? I will tell you. See, this is the first statement, Kelvin Planck statement. Now, what is this Kelvin Planck statement? It is impossible by any thermodynamic process which results solely in the removal of heat from a heat reservoir and convert it entirely into work. Now, what do you understand by this? What do you understand by this thing? Now, I will tell you. See it carefully. I am going to draw a diagram. From diagram, you will come to understand what I want to say. Suppose this is source at temperature T1, or you can say high temperature. Some heat transfer is there. This is system. This is work done by system. This is my system. Let it be heat engine. Let it be heat engine. Okay. Now from source at high temperature, Q1 amount of heat is coming inside the heat engine. Correct. And engine is doing some amount of work. Now, what the statement is saying, it is impossible by any process which results solely in the removal of heat from heat reservoir and convert it entirely into work. Means this system is impossible where system is absorbing heat from reservoir and converting it completely into work. This is impossible. I already told you, total heat cannot be converted into total work. there should be some amount of heat rejection. I already told you. This is impossible. There should be there should be some amount of heat rejection. Okay? So this is the Kelvin Planck statement that there is no system which absorb heat from a reservoir and convert it totally into work. Now what is happening? Suppose this system is taking heat Q1 and converting it totally into W work. What is happening? Efficiency. What is efficiency? Output by input. Output is work. Input is Q1. Okay. Now if total Q1 is converting into total W, so what will happen? This will be Q1 numerator. Okay. And denominator is already Q1. Okay, so this will cancel. It will be 1. Means efficiency is how much? 100%. Is efficiency 100%? It is possible in the real world? No. So this is impossible. There should be some other form of energy. There should be some other form of energy. That other form of energy is nothing but Q2, amount of heat rejected. It should be there. So this is nothing but Kelvin Planck statement. Now it became clear to you. There is no system which can convert total heat absorbed from thermal reservoir into total work done. Why? If it is possible, then efficiency will be 100%, and this is not possible. And I already told you, heat is low grade energy, work is high grade energy. Total conversion of heat into work is not possible. There should be some amount of heat rejected. This is a Kelvin Planck statement. I hope it is clear. Now, same thing, what I told you. Written in the words. It means that it is not possible to get a continuous supply of work from a body by cooling it to a temperature lower than that of surrounding. Okay. Now, statement, Kelvin Planck statement. It is impossible for a heat engine to produce net work in a complete cycle if it exchanges heat only with bodies at single fixed temperature. Now what is that single fixed temperature? Q1. Okay, so it is impossible for heat engine to produce net work in a cycle while exchanging heat from only one body. It is Q1. There is no Q2. This is impossible. There should be some Q2. Okay, I already told you. This is the second law. Now Clausius statement. Second statement is Clausius statement. What is this statement? Again see this figure. What it is written? It is impossible for a self-acting machine unaided by any external agency to transfer heat from a body at lower temperature to a body at higher temperature. Now what does it mean? Suppose there is reservoir source, hot reservoir, there is cold reservoir, sink, and this is the working substance. Now I told you there can be transfer of energy from high temperature to low temperature, but from low to high without any external source, is it possible? No. Same thing is written here. The heat cannot be transferred from low temperature body to higher temperature body without any external agency or external work. We have to do some amount of external work to transfer heat from cold reservoir to hot reservoir. We have to do some amount of work. This is the Clausius statement. So from high to low it is possible by itself, but from cold to high it is not possible by itself. We have to do some amount of external work. This is the Clausius statement. There should be some work input. Something is written here. Okay. So I hope you understand both the things. What is the need of second law of thermodynamics? How it came from the limitations of first law of thermodynamics. In second law of thermodynamics, there are two statements. If someone will ask you, Tell the second law of thermodynamics. You will say, sir, there are two statements. The second law of thermodynamics. One is Kelvin Planck, another is process statement. Now, what is Kelvin Planck statement? It is impossible for any heat engine to absorb heat from one reservoir and convert it into total work output without rejecting heat or without transferring energy to another reservoir. Means Q2 is 0. This is not possible. This is the Kelvin Planck statement. Now what is process statement? It is impossible to construct device operating in a cycle will produce no effect other than transfer of heat from cooler to a hotter body. Means this is device. There is no device which can continuously transfer heat from cool body to hot body without consuming any amount of work. For transferring heat from low temperature to high temperature, you need to do some amount. You need some amount of work input. Some amount of work should be done on the system to transfer heat from low temperature to high temperature body. Okay, this first case is not possible. You need some amount of work input. This case is possible. This is nothing but Clausius law of thermodynamics for second law. Okay. Now, based on this law, there is a small numerical. Just see the numerical, what is written. An inventor claims to have developed an engine that takes in 105 megajoule at a temperature of 400 Kelvin, rejects 42 megajoule at a temperature of 200 Kelvin, and delivers 15 kilowatt hour of mechanical work. Would you advise investing money to put this engine in the market? Now, an inventor has invented an engine. How? What is the function of that engine? That it takes in 105 megajoule of energy at a temperature of 400 Kelvin. Means Q1 is 105 megajoule and T1 is 400 Kelvin. Next, it rejects 42 megajoule at a temperature of 200 Kelvin. Means Q2 is 42 megajoule and T2 is 200 Kelvin. And it delivers work output how much? 15 kilowatt hour. Now, will you suggest him or someone to put money or to invest money on this thing? How you will find this? You have to find efficiency, thermal efficiency and the maximum efficiency. Both things you have to find. Now, thermal efficiency is given by 1 minus Q2 by Q1 and maximum efficiency is given in terms of temperature. I already told you it is 1 minus T2 by T1. Now, T2 is given 200 Kelvin, T1 is given 400 Kelvin. If it is given in degree Celsius, you have to convert into Kelvin. If temperature is given in degree Celsius, you have to convert into Kelvin for the numerical problem. So put the value of T2 and T1, get the maximum efficiency. So maximum possible efficiency is how much? 50%. Now you know efficiency is nothing but output by input. Output is work output and input is heat added. Now output equals to how much efficiency into input. Correct? Efficiency is output divided by input. Bring this input this side, you will get output equals to efficiency times input. Now how much is the efficiency? Just now you have calculated the maximum efficiency 50%, so 0.5. What is the input? Input it is given how much? How much it is given? Is it given? Yes, 105 megajoule. Write down. So you will get 52.5 megajoule. Now convert into hour. How you will convert into hour? First, you have to convert into kilowatt hour. Why? Why? Good question. Why we are converting to kilowatt hour? So the reason is lies in the question. Here it is given delivers 15 kilowatt hour of work. 15 kilowatt hour. It is delivering. This is the claim given by inventor. But how much it should deliver? You for this you have to calculate the maximum efficiency. From maximum efficiency you have found this much 52.5 megajoule of work. Now in kilowatt hour. This mega you convert into kilo. So it will be nothing but 52.5 into 1000 into 1000. Okay. So this is kilojoule. Now hour into hour. For bringing here hour, what you will do? What you will do? You will divide this by yes. Tell. Yes, right. Tell. What you will do to convert into hour? Nothing. Divide this by 3600. Now, why we have divided by 3600? Because in 1 hour, how many seconds are there? 1 hour is how many seconds? 1 hour equals to how much seconds? In 1 hour, there is 60 minutes. In 1 hour, there is 60 minutes, right? And in 1 minute, how many seconds? 60 seconds. So in 1 hour, how many seconds? 16 to 60, 3600. So this is the conversion. How you will convert 52.5 megajoule into kilowatt hour. So it will give you this much kilowatt hour. Okay. So this is the maximum efficiency and this is the maximum output engine can give. This is the maximum output engine can give. But what inventor is claiming? Inventor is claiming that it is giving 15 kilowatt hour. Is it possible? This is the maximum a engine can give. But inventor is claiming this much. So inventor claim is false. Inventor claim is false. It cannot be greater than the maximum possible. So you will not advise anyone to invest the money. You will not advise anyone to invest the money. Clear? In this kind of problem, you have to go for the maximum thing. Okay? And you will find what is the maximum possible output. And you compare this maximum with the claimed. If claim one is coming less than the maximum possible, then you will advise to invest money. See, if claim is coming less than the maximum possible, then you will advise to invest the money. But if the claim is coming more than the maximum possible, you can't advise to invest the money. Clear? So this is the process how you will solve this kind of problem. Am I clear? So in today's session, what you have seen? You have seen two statements of second law of thermodynamics, Kelvin Plank and Clausius statement. This is based on the limitations of first law, that heat can be transferred from high temperature to low temperature by itself, but reverse means from low to high, you need some external agency or external work to be done on the system. Next, you have solved the numerical based on it, and you have calculated the maximum possible thing, and you have to compare with the thing which is claimed by the inventor. Correct? So thank you for today's session. I hope the session was fruitful. So I will meet you in my next session. Till then, goodbye and take care.